Yo, what is going on, guys? Welcome back to Aryaa SK Maths, and it's actually the first video, so it's not really welcome back. But anyways, today we're going to be doing an A-level paper upside down. So, it's for a good challenge, and yeah, so if you can see from the top, it's basically the Edexcel October 2022 pure paper 1. So, it's about, the time limit is 2 hours, so just make a note of the time now. It's 9:23, so let's see if I can stay in the time limit. I actually have not tried to do this upside down, so let's just see. All right, so question 1A. Find the first first 4 terms in a, what is this? Yo, I can't read. Okay, let's try and decipher what this word says. Okay, so we got an A, S, C, E, U, D. Hang on, is that a D? Yeah. Alright, that's gotta be ascending. Alright. So the first 4 terms in an ascending power of 4 of the binomial expansion of this. Okay, I get it. Okay, so we want the first 4 terms of this. Okay, that's light work. So I don't know where I should put this. Okay, let's just put it here. So first 4 terms of the binomial expansion of that. Okay, it's fine. So we got 1 plus 8x to the half. Okay, good start. So how are we going to do this? So obviously have the formula 1 plus x to the n, and that is equal to 1 plus nx plus n minus 1 n over 2 factorial x squared. Just continues like that. So what we can do here is that's just going to be equal to 1 plus 1/2 times x, which in this case is 8, so 8x plus n minus 1, so that is minus 1/2, and n over 2 factorial, which is just 2, and x squared is 8x squared. And that's for the first 4 terms, so we should probably add another term. So the next time is just going to be n minus 2 and x cubed over 3 factorial, like that kind of thing. So n minus 2, what's that going to be? Minus 3 over 2, I think. Minus 1/2 and 1/2 over 3 factorial, which is now 6, multiplied by 8x to cubed. Okay, wait, I actually don't know if it's a calculator. Let's see. Calculators may use anything. I think we're allowed to use calculators. Yo, it's actually so weird. I can't understand anything. I thought I knew how to read English, but guess not. Upside down. Okay, so I'm assuming calculators can be used. So yeah, so if we just simplify this all out, like so, we're going to get 1 plus 4x plus, so let's do something like minus 1/8, I believe. So yep, minus 1/8 multiplied by 64x squared plus, so these have a double minus, and we're going to get 3 over 8 over 6 multiplied by 512x cubed, like so. And what is this? Okay, and we'll just do a bit more simplifying. So 1 plus 4x minus 8x squared. divide that by 6, so actually I can just use a calculator for this. What am I doing? Okay, so just put the entire thing into a calculator. Minus 1.5 multiplied by minus 0.5 multiplied by 0.5 over 6 multiplied by 8 cubed. That should give me my x coefficient, which comes out to 32x cubed. Okay, that was pretty easy, hopefully. I hope I got it right though. So yeah, that is the first question done. I'll just box that. Okay, that was part A. That was 3 marks, so that's a good 3 marks, although that took me 5 minutes, so should probably pick up the pace. Anyways, given each term in simplest form. Okay, we did that. Explain how you could use x equals 1 over 32 in this expansion to find an approximation for root 5. Okay, so we have our approximation, and we know this is equal to actually not equal to, it is approximately equal to the binomial expansion of this, right? Let me just make sure I got that expansion right. So it's 1 plus 8x to the half, yeah. Okay, so that's approximately equal to that. So if we just put x equals 1 over 32 into this, then if we put it into this formula, then we're going to get 1 plus 8 over 32, so 1 over 4 to the half, which is 5 over 4 to the half. And then you can see if you open up those indices, you're going to get 5 over 2. So what that tells you is root 5 over 2 is approximately equal to 1 plus 4, and then we basically substitute all of this stuff into this as well, squared. And then so obviously you can just work out an approximation of 5 over 2 by multiplying everything by 2 on this. I'm not actually gonna do this, and then I'll just put the answer in using a calculator. So 2 and then 1 plus 4 over 32 minus 8. Let's just make sure I'm getting these right. So minus 8 times 1 over 32 squared plus 32 times 1 over 32 cubed. Okay, and that comes out to this fraction, which in itself is approximately 2.24. I don't know if it actually wants me to work it out, because it does just say, okay, yeah, there is no need to carry out the calculation. Okay, so I did just do an unnecessary calculation, but it's all right. So what's the time looking like? So we've spent 8 minutes on 5 marks. Okay, that's all right. Like, we can make up the time later. That is question 1 over. Now we're on question 2. By taking logarithms of both sides, solve the equation. Okay, a nice equation. Okay. So, what is this equation? 4 to the 3p minus 1 is equal to 5 to the 210. I think that's what it says. Okay, doesn't seem too hard, so we take logs of both sides. So probably just take log 4, right? So if we take log 4 of both sides, we're going to get this. And then this is just a number which you can type into your calculator. Then if you move the 3 down here, the exponent down here, then this is just going to become log 4 of 4, which is just 1. So that becomes this is equal to that. And solving for p, just bring this over here so it's a bit easier. 3p is equal to log 4, 5, 210. So p is going to be that. And wait, what does it want me? Given the value of p to 1 decimal place. Okay, so it does want me to actually work it out. So let's just put all of this into a bracket. 5 to 210 plus 1. So p is going to be approximately 1/3 multiplied by log 4, 5 to the 210. Hang on, I feel like this may give me a maths error because 5 to the 210 is going to be a massive number. Yeah, okay. It has given me a math error, so I cannot do that. Let's do this another way. Okay, so okay, let's rub all this out and try another method. Let's move this up here so we have a bit more space. So obviously we have to somehow get rid of that 210. So I think if I take a log 4, a log 5 of both sides, then I'm going to end up getting this, which isn't really going to help me solve p, but it is going to let me get rid of this. So it's going to let me just put that equal to that. And then, how am I meant to solve it from here? Okay, yeah, okay, I think I figured it out. So you can still move it down here. It's just not going to be a nice log. So this is still going to just be like this. Okay, yeah, that's fine because you can still work this out. It's just not going to be a very nice number. So let's just put that over to the other side. Log 5 of 4, like so. And now we just can solve for p. I'll just do this in one step. So 1/3 2/10 log 5 of 4. Okay, so small hiccup, but it's all right. Now we just got to type this into our calculators, see if we get the right answer. Log 5, 4 plus 1. And we do get p is approximately 81.6 to 1 dp. Let's just put this back into our original question to see if we did get the right answer. So 3 times the answer minus 1. And okay, actually I just realized I can't do that because you're gonna have to do 4 to the power of some massive number. So we'll just assume this is right, hopefully. I will check the answers at the end just to show if I'm making any corrections because I do not want to be spreading false information like that. Okay, question 3. Relative, okay. Relative to a fixed origin. So just relative to a fixed origin. Point A has position vector 2i. Okay, I'm just going to write these next to this because I will not be able to use them later otherwise. So 2i plus 5j minus 6k. 3i, so it's basically just giving me a bunch of points. Plus 4k, and point C has, okay, 2i minus 6j plus 4k. Okay, here are our 4 points. Probably label these C, B, A because they're in reverse order, and it wants me to find AB. Okay, this doesn't seem too hard, but that is only part A. So actually, let me just check if the other question had multiple parts. Okay, it didn't. Okay, so part A, This is question 3A. So we have O to A, and we also have OB, and we want to find AB. So how are we going to do that? Well, we can probably just swap this because we know OA is just going to be negative AO, like so. So now we can just do something like, so we know AO is going to be negative OA, and then we can just work out AB is equal to AO plus OB, like so. Okay, not too difficult, and we've got AO is going to be negative OA, which is, if we go down here, 2i plus 5j minus 6k. Just make sure that's right. Okay, I think that's right. And plus OB, which we're just given, so 3i minus 3j. Okay, expand all this out. It's 3i minus 3j plus 4k. So that is going to leave us with AB is equal to I minus 8j plus 10k. Okay, nice. Hopefully that is correct. We've got that, and now we just got to do part B. Okay, not too bad. Although I am losing a lot of time. So we found AB. Now I want to show that the what is this? Okay. Quadrilateral OABC is a trapezium given, what does this word say? Given reasons. Okay, given reasons for your answer. So we basically want to prove that OABC is a trapezium. Okay, this is pretty easy. So basically we've got AB, and if we can prove, basically this is what it's going to look like, I think. So we've got OABC. So basically we've got AB. If we can prove OC is parallel to that, then that would be a trapezium. So we're given OC is just 2i minus 6j plus 4k. Okay, so it appears to me those are not parallel, but maybe there's also another possibility. So if we relabel the points, so if we were to start here, like so. So I think if we can prove now OA is parallel to BC, like that, because assuming this is correct, then OC is clearly not parallel to that, so we got to work out a different way. So we've got OA, and now we've just got to work out BC. So what is BC? Well, if we use the same method as before, this is OB and this is OC. So BC is just going to be negative of this, so equals negative 3i plus 3j minus 4k. Plus OC. So equating things like so, we get minus 3j plus 0, okay. And okay, so that still does not look right. Okay. Let's see if I've got all my numbers correct. Okay, see if I've got the OA correct. So it will be negative this plus that. Okay, negative I, negative that. Okay, so I think, yep, okay, and then negative this plus that. is just going to be negative a. And okay, yeah, so I think we've got AB correct. But now we've got to somehow prove that OABC is a trapezium. Okay, let's continue. Rub this out. So in a trapezium, there's going to be two parallel sides. So in our case, if we've got AB, then OC has to be parallel to that. But I don't think it is. Like, if you look at it, this is not a scalar multiple of that. So those aren't parallel, which means it's got to be a different sort of... It's either AB to OC or OA to BC, because other combinations aren't going to work. But if you add these together, so if you just subtract those two, minus 3, like, yeah, so you get this, and that's BC, and you're given OA. So why is this not maths in? Oh, hang on. I've read C wrong. This is a 16. It's minus 16j plus 4k. Okay. All right, that makes a lot more sense. So now I think we've got... So now you can see if we've got AB... Okay, let's just relabel our trapezium now. So we're going to start OABC. So we've got AB here and we've got OC. So OC is equal to 2i minus 16j plus 4k. So what this is telling me is... you can see like these two are both scalar multiples. So I feel like I've just made a small mistake in the k term somewhere, because maybe this is meant to be 2. Maybe this. Let's see. That's definitely a 6. 6k. That's definitely a 4. And if we've got... So we'd wanted to work out negative 6, okay? Okay, I'm just going to work out AB a different way, because another way you can work out 2 point vectors, like the thing between them, is you can just literally subtract them from each other. So if we want to work out AB, then we just do OB minus OA, and that will also give us the point vector. So let's just do that. We can do that here, actually. So we've got I minus 2j no minus 8j plus 10 still gives us the plus 10. So I'm slightly confused on how we're going to get a 4. Plus 4k minus 16j. Let's just make sure I got the numbers correct. 6k, 4k, minus 3. Oh, that's a minus. Oh my god. Oh my, silly me. Okay, so now we can actually work this out. So if we just subtract both of these, now you're going to see if we do minus 4 plus 2, that's going to give us plus 2, not plus 10. Okay, there we go. So write this down. I minus 8j plus 2k. Man, I lost a lot of time on that question. But anyways, now you can see that OC is equal to 2AB. Therefore, they are parallel, and therefore OABC is a trapezium. Okay, question 3 done. Man, this is rough, man, this is rough. Hopefully I can just get an equation so we can speed through it. Let's see what this is. The function f is defined by f of x is equal to that. Okay, that's fine. So f of x, let's make sure I get these numbers right. So f of x is equal to 3x minus 7 over x minus 2. And it wants us to find f of the inverse of f7. Okay, so let's just work out what... Actually, let me think about this. What this is saying is find what value of x is going to give you 7. So I can actually just solve this without having to find the inverse. So let's label this 4a. And we want to find what value of x gives us 7. So pretty easy. Let's just cross multiply. 3x minus 7. 4x is equal to 7. And x is equal to 7 over 4. Okay, let's just put this into my calculator. Make sure I got that one right at least. So 3 over x minus 2. Okay, yeah, so we got that bit right. Now let's do the next bit. 4b. Show that f of x is equal to that, and find these constants a and b. Okay, pretty good. So f of x is basically just substituting... wait, I probably should have given myself a bit more space for this. Okay, let's just move this up a little. Okay, 4b. So f of x is just going to be substituting this into the x. So we've got 3x minus 7 over x minus 2 minus 7 over, and then we put it in again here. And now I'm guessing we just have to simplify this, which is pretty good. Okay, should be able to save time on this. So first of all, multiply the top row by this, and 9x minus 21 minus, and then we're going to put 7x okay, and plus 14, I believe, over 3x minus 7, and then if we're going to minus 2, so minus 2x plus 4. So basically what I did was converted this 7 into 7x minus 2 over x minus 2, and then I just expanded it like this. And then it's going to give you the entire denominator as over x minus 2 over x minus 2. So you can multiply the top and bottom by 1 over x minus 2. No, just x over x minus 2, and they'll cancel out. So, yeah, and then you got to remember the minus, so you just flip it. But yeah, okay, so, and then we just draw all this out. So 2x minus 7 over x minus 3. Okay, and that's f of x. So we have now got, so we've got a is equal to 2 and b is equal to minus 7. All right, that is good work. Okay, question 5. A car has 6 forward gears. Oh no, I do not like the look of this question. Car has 6 forward gears. The fastest speed of the car is in first gear is 82 kilometers an hour. Okay. So first gear, 82 km per hour. I think that's what it says. 82 km per hour. Okay. In sixth gear is what's that say? 115 km an hour. Okay. So, what does it want me to find? Given that the fastest speeds of the car in successive gears is modeled by a... what does that say? I think arithmetic sequence. Find the fastest speed of the third gear. Okay, so they're basically saying it's an arithmetic sequence. Okay, that's good. That's actually easy. So we've got 1, 2, 3, 4, 5, 6 gears. And so first gear is 82 and sixth is this. So basically an arithmetic sequence means everything is added by some x. So what this is saying is we can just work out this x because we're given 82 plus 1, 2, 3, 4, 5x is equal to 115. So then we just work out what 5x is. 115 minus 82 is in fact 33, so x has got to be 6.6. Okay, and I guess we can just test that, and then we can just use this to fill in all the gaps. So answer plus 6.6. So the second gear is going to be 88.6. Third gear is going to be 95.2, which is what we're trying to work out. But I'll just put all the other ones in case we need them later. 108.4, and then the final one is 115. So therefore, let's write this. What question number is this? 5A. Therefore, the third gear is 95.2 km per hour. I think that's the format they gave it in. Okay, now part B. Given that the fastest speeds of the car of successive gears is modeled by a geometric sequence, find the fifth gear. Okay, so now it's the geometric sequence. Okay, this wasn't actually too bad. Like, I thought it was going to be a lot harder. So we've got 82, that's the first, and then let's just make sure I get these numbers right. Oh no, I think I got the numbers wrong. That's not 82, that's 28. Oh no. Okay, let's fix our little errors. So it's actually 28, which means this algebra is wrong, so is that number. Okay, so 28 plus 5x, so 5x is actually going to be equal to 87, so x is equal to, what's that, 17.4. Okay, so small hiccup again, but now basically third gear is just going to be 28 plus 2x, which is 28 plus 2 times that, which should just be 28 plus 2 times 17.4, 62.8. Okay, there we go. Let's make sure I got that right. 28, 115. Okay, I think that's right. 28 answer plus 17.4. Okay, now we can use our geometric sequence. So I'll just put them like so. So we got the second, third, fourth, fifth, and then sixth gear like so. Then geometric sequence, we're actually just multiplying everything by a common ratio. So this time we've got 28 times r to the 1, 2, 3, 4, 5. So r to the 5 is equal to 115. So we can just solve for r now. Is just going to be 115 over 28, which is, okay, I'm just not going to simplify that because that's a weird number. So we get r is approximately equal to the 5th root of that, which I'm just going to put this into my calculator. 5th root of that is going to give me about 1.3265. So now we can just work out the 5th one, but instead of going all the way along, I can actually just do, since this is multiplied by r, if I'm going this way, I can just divide by r. So the 5th gear is going to be 115 divided by that, 3265, which is divided by 1.3265, which is 86.7. Does it ask me for decimal places? I'll just give it to one decimal place. So 86.7 kilometers per hour. And there we go. And let's just ensure that is correct. So second is 37, third is 49, fourth is 65, fifth is 86, and sixth is 114.9. So yeah, that's good. Okay, good work. Number 6. Oh my god, this is a lot of working. Express sine of x plus 2 cos of x in terms of r sine. Okay, nice and should be easy question. So what they're basically saying is sine. Okay, let me just write this out. Is this 6? Okay, 6a. So sine of x plus 2 cos of x is identical to r sine of x plus alpha. Okay, now I'm pretty sure what we can do here is we can just expand this out. So that is equal to, if you remember your sine things, let me see if I can remember them. So I'm pretty sure sine is going to be sine x cos alpha plus sine alpha cos x, like that. Okay, and they're saying this is equal to that. So what do you want me to do with this information? Okay, let's expand this out further. R sine of x cos of alpha plus r sine of alpha cos of x, and that's identical to this. Okay, so I think what you can see here is the coefficient of this, that's just 1, right? So the sine of x term, we can make two equations. We've got r cos of alpha is equal to 1, and see the coefficient of the cos of x is 2. So if we just get rid of that, and then we've got r sine of alpha is equal to 2. Okay, so now we've just got two equations and we've got to solve for r and a. So you can do simultaneous equations, and probably the way you solve these, I'm pretty sure, is you just square both sides. So r squared cos squared alpha is equal to 1, and r squared sine squared alpha is equal to 4. Then you can add both of these together and you'll get r squared, just factor it out. So you get sine squared a plus cos squared a is equal to 5. And if you notice, this bit is just going to be 1. If you remember the identity, sine squared x plus cos squared x is equal to 1. So you end up with r squared is equal to 5. So r is the root of 5, okay? And then we can just plug this back into one of our equations. So let's just put it into number 1. So root 5 cos alpha is equal to 1. So alpha is going to be arc cos of 1 over root 5. Which is, does it ask me for any decimal places? Where r and constants, and r is greater than 0, and a is between 0 and pi over 2. Okay, so we've got the r constant. Now hopefully this should just give us something between 0 and pi over 2, although, okay, I'm going to have to put my calculator into radians. Okay, now arc cos of 1 over root 5, that is 1.107 for 3 decimal places, which I think is correct. It is between 0 and pi over 2, so okay, so that's part A done, I believe. Now we can say this. What is this equation? The temperature theta degrees C inside a room on a given day is modeled by the equation, by that equation, okay? Where T is the number of hours after midnight, using the equation, of the model and your, what does this say? What's this word? And your answer to, part A, wait, I think, okay, so what is this word? Deduce, okay. Deduce the maximum temperature of the room during the day. Okay, so this is the model. Let me just copy this out over here. The model theta temperature is given by 5 plus sine of this, what's that? Pi t over 12 minus 3 plus 2 cos of pi t over 12 minus 3. And you are given okay, that makes sense. So using our part, we can tell that this can also be written, this part can also be written in this form, and we have those coefficients. So if we just say x is equal to the brackets, then we get root 5 sine of this, pi t over 12 minus 3, plus a, So we got the plus a here, which is just 1.107, and I believe that is, okay, yeah, good. And then plus 5 for this thing here. So this is our new model, the same thing. And we want to find, what's it want us to find? The maximum temperature during the day. So that's basically just finding a maximum. And to do that, we'd have to find the derivative of this. So d theta over dt. Wait, one sec. Let me just simplify this. So minus 3 plus answer, just so we have slightly easier stuff to work with. This is minus 1.8709. Yeah, okay. And is that right? Yeah, okay. And now we can just work out the derivatives. So if this is just going to disappear, and this is just going to turn into root 5 cos of this minus 1.89029 multiplied by the derivative of the inside, which is just pi over 12. Okay, and we want to see when that's equal to 0. d theta over dt is equal to 0. Man, I should have given myself more room. Yeah, I guess I can move this stuff up here. Let's just move this all up here. Cut that. And put it in. Oh. Here. Okay. Here we go. Now I have more room to work with. Pretty good stuff. And if we say when this is equal to 0, this whole expression is going to be equal to 0 cos of this 12 minus 1.8929 times that is equal to 0. So obviously we can just divide everything and we can get the expression like this, and that is going to be equal to arc cos of 0, which I'm pretty sure is just 1. Oh, but we are working in radians. I have forgotten about that. So arc cos of 0, that is basically 90 degrees, but in radians that's pi over 2. Okay, good. And we just got to solve this now for t, so I'm just going to do this all in one step. So if we move the 12 over pi onto this side, then we've got pi over 2 plus 1.8929, which is going to be approximately find the time of day. Yeah, I think I'll just give it in terms of t. So that's just going to be equal to typing this into my calculator, and you get pi over 2 plus 1.8929, which is 13.230343. So that's the number of hours, and that's the number of hours after midnight. So, there's actually an easy way of converting this into hours, minutes, and seconds. So I believe if you just click the things, yeah, so you get 13 hours, 13 minutes, and 49 seconds. So this is the time of day, I believe, although it might be 1 hour off due to the midnight things, but yeah, this was the value of t which you want. So yeah, hopefully that's correct, although I'm not feeling very confident because that question had a lot of writing. It's pretty easy if I just made a small mistake somewhere. Okay, let's move on. Figure 1 shows a sketch of a curve C with equation y equals f of x, okay? The curve meets L at the point, okay, I'm just going to write this point. So minus 213. Yep, makes sense. Minus 213, and also 25, 0, 25. Okay. The what's it say? The SHAP. Oh, the shaped region R is is bounded. Okay, is bounded by C and L, as shown in figure 1. given that f of x is a quadratic function and minus 213 is the minimum, minimum turning point of y equals f of x, use, what does this say? Use in a day UELITI inequalities. Use inequalities to to define R. Okay, so you want to define R in terms of inequalities, and 5 marks for that. Okay, this is actually looking like a nice question. So f of x is a quadratic, so ax squared plus bx plus c, and you're given minus 2 is the turning point. So what you can do is, it's going to be something like, if you put it into completed square form, it's going to be x plus 2 squared minus 13, no, plus 13. But obviously when you complete the square, the coefficient of the squared bit doesn't really matter, so we still have this, and that's why we use this y-intercept to work it out. So we know when f of 0, that has to be equal to 25, and 0, 25. So if we put a and x is 0, so 2 squared plus 13 is equal to 25. 4a plus 13 equals 25. 4a equals 12, so a equals 3. Okay, so we've got our quadratic. Although, I don't think that really helps. Okay, so we've got curve C, y equals f of x, which is equal to 3x plus 2 squared plus 13. And we've also got the line L, so I guess it wants us to work out what L is. So that shouldn't be too difficult because it's just a line. So we've got y equals mx plus c, and we can just work out m doing changes. So minus 2 minus 0, sorry, needs to do change in y first. So I'll do this point minus this point. So we got 25 minus 13, which is just 12, over 0 minus 2. So 12 over 2x plus c, y equals 6x plus c, and since we have the y-intercept, we can just say we know c is equal to 25. So L is y equals 6x plus 25. Let's just make sure that works. If we put in minus 2 into that thing, you get minus 12 plus 25, which is plus 13. Okay, good. And now we just need to define a region. So run out of space again. Maybe if I just make a bit more space here. So I think first of all we need to define, it's when x is greater than, you can see it's like coming above c, so that's when it's greater than c. So y has to be, and it's straight line, so it's greater than or equal to. So y is greater than or equal to 3x plus 2 squared plus 13. And that's just going to give us this entire thing. So we also need to show, and it's when it's less than this, less than L. So, and y is less than or equal to L, 6x plus 25. I think that should be it, actually. Let me just think. So, yeah, so less than L is going to give us this, greater than C is going to give us this, so therefore the total area is only that. So yeah, I think these are our two inequalities. I guess I could just number them, but yeah, those are our two inequalities. All right, good work. Moving on. Question 8. A new a new smartphone was released by a company. The company monitored the total number of phones sold. Why is there an N apostrophe? Phones sold N at time T. Oh, so I guess it's just saying N is the number of phones sold time T after the phone was released. The company OBSER observed that during this time, the rate of increase of N was proportional to N. The rate of increase of N was proportional to N. So is that just a differential equation, I guess? So dn over dt is proportional to N. Use this information to write write down a suitable equation for N in terms of T. In terms of T, okay. So I guess I have my differential equation. That's the wrong sign. Got my differential equation. So you know dn over dt is proportional to N, which means let me just see, is proportional. Yeah, so proportional to N, so that means dn over dt is equal to k times N. Then I guess we just got to solve this, so in terms of T. So we want to get it into the form T equals N, like so. So I guess we kind of just solving this differential equation. Pretty good. So we've got 1 over kn dn is equal to dt, if we just move them like so. And then we just solve this, so take the integral of both sides, move the k outside, and you'll end up with 1 over k times the natural log of n is equal to t. Okay, but you gotta add the c. I'm just gonna add it on this side. So, like so. So you got t is equal to 1 over k times, but if you think about it, 1 over k is just another k. So I might just leave it like this. I might just put just k like that. K times the natural log of n. I believe n is always going to be positive, so the absolute signs don't really matter. But, and then plus c. So, pretty good, I think. That was fine. Okay. That is my suitable equation. Okay. Question 9. Figure 2 shows a sketch of the curve C with equation y equals f of x. Oh no, what is this? F of x equals 4x squared minus 2 e to the minus 2x. Okay then. show that f dash of x, so just find derivative of this. Okay, pretty good stuff so far. So 4 times x squared minus 2 multiplied by e to the minus 2x. Let's just find derivative of that using product rules. So I'm just going to bring constant multiple 4 outside. Then we use product rules. So derivative of this function is just going to be 2x multiplied by this, and adding x minus 2 multiplied derivative of this, which is just minus 2e to the minus 2x, like so. So now we can expand this out. What does it actually want me to show though? That it's equal to 8 something e to the minus 2x. So it wants me to take out a factor of 8. So I'll just do that once I've expanded this out. So you've got the minus 2, you've got the 4. So I'll just move all that to this side, minus 8 x squared minus 2 e to the minus 2x. And then you should be able to see that I can factor out an 8 on this side and a e to the minus 2x on the other side. So 8 minus x squared minus 2 and e to the minus 2x, like so. So you get f dash of x is equal to 8, and then what does it want me to do? 2 plus x minus x squared e to the minus 2x. Okay, that was fine. That was quite good so far. Question B, hence find in simplest form the exact coordinates of the stationary point of C. Okay, so find a stationary point of this. Let me just move all this over here so I can get more space. And let's just put that here. So we want to find when f derivative is 0. So I'm just going to do this in my, just explain it for here, so I don't have to write it all out. But basically, if we were to equate this to 0, then you can see this is either equal to 0 or this is equal to 0. So let's just make our equations. So we've got e to the minus 2x is equal to 0. And you can see this is going to give x is undefined, because if you take lns of both sides, you're going to get minus 2x equals ln 0. This is undefined, so therefore x equals undefined. So no solutions from that, which means we're going to get all of our solutions from putting this equal to 0. And you can just divide the 8 on both sides to get rid of it, but you'll end up with this quadratic. 2 equals 0. X squared minus x minus 2 equals 0. I think you can factor that. Yeah, x minus 2, x plus 1 equals 0. So these are our two coordinates. Does it want the coordinate or just the x coordinate? Find the exact coordinates. Okay, it does want the coordinate. Of course it does. So we have our x, and we can just plug this into this equation over here. So when it's 2, so 4 times 2 squared minus 2, 4 times 2 e to the minus 4, like so. And the second one is when you put minus 1 into that, you get 4 times minus 1 squared, so 1 minus 2 minus 1 e to the 2. And okay, so our coordinates are 2, multiply out these, 8 e to the minus 4, and minus 1 minus 4e squared, like so. Those are the coordinates of the stationary points. Let's see if they make sense. Minus 1 and minus 4e squared is approximately minus 29, so that's this point. And then 2, 8 e to the minus 4 is 0.29. 4, 6. So that's this point, although the scale's a bit weird. So let's just make sure I got that right. So 2 is probably correct, but then if I put this into here, 2, 4 minus 2, 2, and then minus 4. Yeah, this seems right. Okay, so these are our 2 coordinates. And then finally, for part C, let me just move this all up now. Right, put that over here. And the function g and the function h are defined by that. G of x is equal to 2f of x, okay? H of x equals 2f of x minus 3. Find for part CI, the range of g. Okay, it wants the range of g. I think we might be able to work this out by just looking at it. So g of x is basically h of x, but times 2. So it's going to be stretched by 2 in the is it y-axis? Yeah, it's going to be stretched like this. So the points are going to be 2 times larger, which makes sense. So the range, so I think on this side, it goes to positive infinity, right? If we just put smaller and smaller numbers into f of x, we're going to end up getting, if this goes to x is, let's just say x is like negative a million, that's going to go to like a trillion, and although, is it going to be, because this is then going to be, yeah, this is going to be positive. So yeah, this is going to go to infinity on this side, and this is the lowest point it's ever going to go. So the range of g is going to be 2 times this point, and we know that's here. So I believe this is the range. It's going to be equal to that, and it's going to be less than infinity, although it just seems a bit weird. I don't know if it's going to be infinity, but I feel like it should. Okay, yeah, hopefully that's right. So the range of g and the range of h. So h of x is just g of x, but minus 3. So it's the equivalent of just having this, and you're just translating it 3 in this direction. But this is still going to be infinity, and this is going to be 3. So I think the range of this can be 8e to the 2 minus 3. H of x can be that, and it's still just going to be infinity, I think. I hope. Let's just make sure I got that 8e squared correct. So I got that from x equals minus 1. I'm putting that back into this equation. We do, in fact, get minus 1. So that's going to be minus 4, and then 2. Yeah, so it is e squared. So yeah, I think this is correct. This is correct. Obviously, I will just show you the answer at the end, because there's a high chance I'm getting like most of these wrong, but you know. Anyways, an integral, okay, this is good. And use the substitution x equals u squared plus 1 in this integral to work out okay, so it just wants me to work out that. It just wants me to change it, actually. Okay, let's write down this integral. So we got 5 to 10 of 3 over x minus 1, 3 plus 2 root x minus 1 dx. Okay. Okay, and it tells us to use the substitution x is equal to u squared plus 1. Okay, I think the first thing I'll do is I'll just work out what dx is. So dx is going to be 2u du. Now, does that help at all? What am I seeing here? So if I put x into this part, that is just going to cancel out to u squared. And if I also put it into this, it's also going to cancel out to u squared. Yeah, okay. I guess I can just... Okay, yeah. So let's just put this in. Move this up here. And also going to have to find new bounds. So we know x is going from 5 to 10. So if we just put u squared plus 1 is equal to 5 and is equal to 10. So you can see you're going to end up with u squared is equal to 9. So u is 2 and 3. So the new bounds are going to be this. So when we transform this integral, it's going to become 2 to 3 of 3 over, and then putting x into this, u plus 1 minus 1 is just going to simplify to u squared. And same kind of thing here. 2 times put x into there, and you get u squared like that. And you already have dx like this. So times 2u du. Okay, this actually looks pretty easy now. And what form does it want me to get it in? So 60u, so it does not want me to change that, and then just fix the denominator. Okay, and so that is equal to 6 du 2 to 3 over, if we just fix up this denominator, u squared multiplied by 3 plus 2u du. Oh, don't need that, I'll just put it here. Plus 2u, which is 2 to 3, 6du over 3u squared plus 2u cubed. Is that the form it wanted me in? Oh, no, it is not. 3 plus... It wants me 3 plus 2u. Ah, I see. I'm so silly. So, we've got this. And if we basically move this up here, we're going to get a 6u du like so. And then the u's cancel out. 6 du over u, 3 plus 2u. And that is the form they wanted. Okay, and then we've got this. Hence, using algebraic integration, show that that is equal to natural log of something. Okay, so now we just want to solve this. So part B, what question is this? 10a. And part B, we're just going to solve this integral. So I'm just going to write it out again. I think this is by partial fractions. So let's do that. So basically what we are saying is 6 over 2, 3 plus 2u is identical to a over u plus b over 3 plus 2u. So using our identity rules, we can just say not using identity rules, just cross multiplying and then cancel out denominator. You can see that this is going to be equal to 6, identical in fact, and then now we can just put in our u values. So if we say u is equal to 0, then this is just going to cancel out, so we're going to get this is going to go 3, so 3a equals 6, a equals 2, and if we put u is equal to negative 1.5, then you can see this is going to go to -3. So that's going to go to 0. And you get -1.5b is equal to 6. So b is equal to -4. I believe so. Yeah, okay. So that allows us to transform this integral into this now. 2 to 3. 6 du over u. And we put it into this form. So 2 over u minus, oh, that looks way too much like a 4, minus 4 over 3 plus 2u du. Okay, and from here, it's pretty easy to solve because you can just put it into lens, just like that. Oh, but it wants the exact value. All right, so this is just going to be 2 ln u minus, and then 4. If we do the u sub, it's going to become 2. So minus 2 ln 3 plus 2u. Like so. Put in these two numbers, and let's see. If you were to put w equals 3 plus 2u, then dw is equal to 2 du. So du is equal to 1/2 dw, and then the 4 goes to, yep. Okay, and let's just evaluate this over these limits. So 2 ln 2, 2 ln 3 minus 2 ln 3 plus 6 minus 2 ln 9 minus 2 ln 2 plus 2 ln 3 plus 4, 7. Okay, and now we just gotta put it all in, which is equal to, if we factor out the 2, now we get ln 3 over 9, and then let's put this plus ln 7 over 2, like that, and then we can just simplify this. When you multiply those two together, 2 ln 21 over 18, which is equal to 2 ln 7 over 6. So ln 49 over 36 is the final answer. Does want an integer though, where a is a rational constant of, what's this? Oh, a is a rational constant to be found. Yeah, this seems about right. So 1/3, 2 6, and then when you put the 2 up there, you square both sides. 49 over 36. So yeah, that seems right. Okay, this is good. We're back on track, I think. We have about 40 minutes left, and I don't know how many questions, although we are only halfway through. It says 30 out of 52, so I don't know if we'll finish this on time, but, you know, yeah. So circle C1 has equation x, x squared plus y squared is 100. Circle C2 has equation x minus, wait, let me write this now. C2 x minus 15 squared plus y squared equals 40. The circles meet at point A and point B as shown in fig 3. Yep. Show that angle AOB is equal to 0.635 radians to 3 significant figures, where O is the origin. So you basically want to find the angle AOB. So this, okay, does not seem too bad. I guess the first thing I got to do is work out the point of intersection between those two things, so I'm probably just going to subtract both circles from each other. You've got x squared plus y squared equals 100, and you've got x minus 15 squared plus y squared equals 40. Like so. So first thing I'm going to do to work out the points of intersection is subtract both, and apparently, so the y's will cancel out. X squared minus x minus 15 squared is equal to 60. X squared minus x squared minus 30x plus 225 equals 60. And now the x squareds cancel out, so you're left with 30x minus 225 equals 60. So x is just going to be 1/30 of 60 plus 225, which is, just typing this into a calculator, 60 plus 225, 19/2. Okay, so basically what this is this line, x equals 2, x equals 19/2. That's the line which they both on which they both intersect. So now you can just use this and plug this into one of the formulas. I'll just put it into this one to find both points of intersection. So if we put 19/2 squared plus y squared is equal to 100, then we get y squared is equal to, actually I'll just put it all in one step. So y is equal to plus or minus root of 100 minus 19/2 squared. And the two solutions we get for that are in fact 100 minus 19/2 squared. So that is 3.122499 and plus or minus. So 2 points of intersection are going to be 19/2, so what's that? 9.5. So positive 9.5 and positive 3.122499 and negative 9.5 and negative 3 point that. Okay. Okay, so we have our 2 points of intersection. So now we could use these points. Like, there's actually a lot of ways to work out this angle, but we basically want this angle. The way I'm thinking, you could either use dot products, but it seems a bit much. But also, if you can work out the height, which you already know, because you know this x product, then you can just work out the area of the triangle, and then you'd also have to work out what this length is. So I think we're gonna have to work out the length OA either way, but that's pretty easy because it's just going to be square root of both those things combined. So let's put that in, 9.5 squared plus answer squared, and that is exactly 10. Oh, I'm so silly, man. I should have known because it's the radius. Okay. Right. Anyways, so that length is 10, and we're looking for this angle. So what we can do is we can just use area. So if we say the area of AOB is going to be 1/2 base times height. So the base is twice this length, 2 times 3.2 this, times the height, which in our case, okay, yeah, I just realized I also need to work out the height. Well, actually I do know that because we know the x coordinate of their intersection is just going to be 19/2. So, oh, this should not be a -9. because these are always 9.5. So 19 over 2, and that is the area, which is also the same as 1/2 AB sine C. So 1/2 10 times 10 sine theta. So all in all, we can just work out theta using this stuff. But this is going to be this is a lot of stuff to simplify. So first thing I'm going to do is get rid of the halves on both sides, like that. 100 sine theta is equal to that. So if we just say theta is equal to arc sine of that and do it all in one step. So I'm going to move this 2 over here to get 19 times 3.12499. Yeah, minus 2, 3.199. And if we move the 100 over to this side, we'll get that, and to 3SF. Now we just put all of this in. Hopefully this is the right answer, because I'll be pretty annoyed if it's not. Over 100, and okay, and we get 0.194. I've definitely made a mistake somewhere. What has gone horribly wrong here? 1/2 AB sine C, okay, got that bit right. And we also wanted to work out the area of this. Height of that is just going to be 2 times the y, yep, times the height, which is 19 over 2, yeah. Let's make sure I put it all in. Oh, I believe I've made a mistake. Okay, this is good. I made a mistake while putting it into my calculator. I put 19.3 when it was actually meant to be 19 times 3.1. Okay, there we go. And we do get 0.635. Okay, that was only 4 marks as well. Okay, let's move all of this up here and cut that. Oh. Okay, put this over here. So we've got that angle. Now, what does it want me to do? So the region shaded is in figure 3 is bounded by C1 and C2. Yep. Find the perimeter of the shaded region. It wants me to find the perimeter. Okay. Let me just think. So obviously we have this entire angle here. Let's use the laser. Okay. So obviously we have this entire angle because it's just going to be this. But the one we don't have is this angle. How am I going to work that out? I guess we could just work it out in the same way we worked out this angle. I feel like that's just a waste though. Is there a better way of doing it? Is there a better way? Okay, it's alright. For now, we'll just work out this. So, perimeter of C1. So we've actually got this angle. I'm just going to write it 0.635 to 2SF. So the opposite of that is just going to be 2 pi minus that when you do that. So 2 pi minus 0.635 over 2 pi, because we're going to take out the whole sector, and 2 pi minus that. Yeah, and then we just got to times it by the diameter of this, pi times diameter. So times pi times the diameter, and we know the radius of this is 10, because It's got that. So diameter is going to be 20. So times 20 times pi. Okay. And does it want it exact? Oh no, 1 decimal place. Okay. So that just lets me type it in straight away. 2 pi minus 0.635 over 2 pi times 20. And that is equal to 56.4818537. So that is this perimeter. Now we just got to work out this, and I'm trying to think of a better way of doing it, because I really don't want to have to work out this angle. You know, I think we might just have to. Work out this angle, man. Okay, we will just work out the angle here then. So I'm gonna label this angle phi. Let's see though. Can I use any circle theorems to let me do it a different way? That's not a tangent, so probably not. Okay, we'll just work it out. So we know these points of intersection. Yep, we do, and we can just work out a similar sort of triangle. So we know the length of that is the diameter, as the radius. So from this, r is going to be root 40, which is just 2 root 10. So radius of that, so the area of this triangle is, wait, I think I just realized. Actually, no, it's fine. Yeah. So just realized, because the other way I did it wasn't really valid, because I worked out the area of this triangle and equated that to the 1/2 AB, but that was kind of just, that would have taken into this account. So maybe it was just a rounding error. Just realized that was a bit weird, but it's all right. So yeah, we can work out the area of that, and okay, yeah, actually I think the other way was right. Yeah, it was valid, because these are actually going to go like that. So these are valid points of intersection. Okay. Yeah, sorry about that. Anyways, so we've got our two radii like so. So we've got 1/2 times base times height. So the base is just going to be same as before. 1/2, 2 times 3. Let's see if I can remember it. 3.122499. 3.122499. And that's the base multiplied by the height, which is just it's not, so this is 15.0. Okay, and this point is 9.5, so the base is going to be 15 minus 9.5, which is 5.5. Okay, or just, what's that, 11/2. Okay, so this is the area of that triangle, and that's equal to 1/2 AB, 1/2 AB squared, which is just going to be 40 sine phi. So first of all, cancel out like before. Arc sine of that, 11 times 3.122499 over 40. So phi is equal to arc sine of 11 times 3.122499 over 40. Okay, and that is about 1.0327 radians. Okay, there we go. We've got our angle. Now let's just work out the other one. So perimeter of C2 is just going to be 2 pi minus e minus 1.0327 over 2 pi multiplied by pi multiplied by the diameter, which is going to be 2 times the radius, so 4 root 10. And that should give us our answer. Okay. Okay. 2 pi minus answer over 2 pi multiplied by pi multiplied by 4 root 10. 33.20696.811. Okay, there we go. So the total perimeter is going to be that plus that, which I'm not going to write it all out again because it's right there, but let me just add this onto my answer in the calculator. 56,85307, and that is 89.1 decimal place, so 0.7 to 1 decimal place. Whew. Okay, that was actually a pretty rough question, but it's alright. I hope I got that right, because I'll be pretty upset if I didn't. Let's just do a quick test to make sure it can be right. So we can work out the radius of you can work out the circumference of each circle, so it's going to be 2 pi times 10 plus 2 pi times 2 root 10, which is just going to be, that is 102, so that's less than that. So yeah, it's looking promising, Okay, question 12. In this question, you must show all steps of your working. Okay, I can do that. Show that cosec of theta minus sine of theta is equal to cosec multiplied by cotangent theta. Okay, pretty good stuff. Starting off, 12a. What have we got? CSK of x, CSC of x of theta is equal to theta minus sine of theta, and they're telling me it's identical to cos theta cotangent theta. Okay, so let's just start working. So we've got, that's the same as 1 over sine theta minus sine theta, which is equal to sine squared theta over sine theta, which is equal to 1 minus sine squared theta over sine theta, and that's equal to cos squared theta over sine theta, which is cos theta multiplied by cos theta over sine theta, and that's just equal to cos theta times cotangent theta. So that's the first part, solved nice and easily. Now, part B, hence or otherwise show for x between 0 and 180 degrees of cosecant of x minus sine of x is equal to that. Okay, now we want to solve this equation. CSC of x minus sine of x is equal to cos x cotangent 3x minus 50. Okay, now if we use the part from above, we know that this left side is just the same as cos x cotangent x, and that's equal to that. And now what we can do is just divide both sides by cos x, but that'll give us an equation. It feels equal to 0. So one solution would be, if we're working in degrees, this would be 90. So that's one solution. I don't know how many solutions there are though. Okay. So it's between x and 0 and 180. So yeah, that is one of the solutions when x is equal to 90, because yeah, and that leaves us with cotangent x is equal to cotangent 3x minus 50. Oh, okay. So I need to remember my rules. So I'm just going to convert this into tan. So 1 over tan of x is equal to 1 over tan of that. And if you know your tan identities, I'm pretty sure tan of x is equal to tan of x plus 180. That is a thing. So okay, yeah, so one equation would be x is equal to, actually I've already labeled one. Got a second equation, x is equal to 3x minus 50. That's the easy one. So minus 2x equals minus 50. So x equals 25. That's the first equation. And the second/third equation is going to be x is equal to 3x minus 50. Wait, I'll add the 180 on this side so we can probably get it in the range. 3x minus 50. And now just solve for this. Minus 2x equals minus 230. So x is equal to minus... Okay, my plan backfired because that doesn't give us the equation we want in the range. So we'll just do it the other way around. Minus 50 plus 180. And minus 2x is equal to 130. Actually, I'm going to solve it for the general case so that we can just get as many solutions as we need. So x is equal to 3x minus 50 plus 180 n, and n is an integer. So if we just solve it for this general case, we get minus 2x is equal to minus 50 plus 180n. So x is equal to minus 1/2 this. And depending on how many solutions, so x is between 180, 0 and 180. So let's say n is equal to 1. Okay, that's not going to work. We want n to be negative, yeah, because then this is going to be negative, so we're going to get a positive value. So if we say n is equal to negative 1, then we're going to get x is equal to minus 1/2 times minus this minus that, which is going to give us, putting this into the calculator, minus 50 minus 180, 115. Okay, there's a real solution. Nice. Okay, so I'm just going to box my solutions. We got 25, 115, and 90. Let's see if we can get another one. If we put n equals minus 2, just put this straight into my calculator. So times 2. Oh, so now we get 205. That is outside the range, so we can't have that one. So we have 3 solutions, 90, 25, and 115. Okay, okay. Actually making pretty good progress for going in this paper downhill. I don't know how close I am to finishing it though, but I feel like I'm not going to finish on time, but we'll see. So, okay. A sequence of numbers A1, A2, A3 is defined by A n plus 1 is equal to k an plus 2 over an. Okay, where k is a constant. Given that the sequence is a periodic sequence of order 3, I think that means it basically just like comes back to the same value every 3 iterations, like so. So it's just like if it was 1, it just keep coming back to 1 like that. Yeah, so given that it's a periodic sequence, so you're given A1 is equal to 2. Okay. So A1 is equal to 2. Since it's a periodic sequence, you know, and order 3, so that shows, now you know A4 is equal to 2, A7 is equal to 2, and A10 is equal to 2. That's what that's saying. So we've got some terms, and we want to show, and we want to basically find K. Okay. So what I'll do is I'll probably just try and get A of 4 in terms of A of 1. So let's write down the formula. A of n plus 1 is equal to K an plus 2 over an. N plus 2 over an. Okay, so we've got A of 2 is just going to be K times A of 1, which is just 2 plus 2 over 2. So that's 4k over 2, so 2k. Okay. A of 3 is equal to 4k. So we put 2k into that. So k multiplied by 2k plus 2 over 2k, which is 2k squared plus 2k over 2k. What? Okay, I mean, that does actually make sense because these you cancel out and then all of that cancels out. So you'd end up getting A of 3 is equal to k plus 1. And therefore A of 4 is equal to k plus 1 plus 2 over k plus 1. So that's just, I'll just rub this out and put that as equal to plus 3. So k squared plus 3k over k plus 1. I don't think I can simplify this, but luckily we know what A of 4 is. So I just bring this over to here. I know it's getting a bit messy, so I'll try and box stuff off, make it a bit clearer. So we've got k squared plus 3k over k plus 1 is equal to A of 4, which is equal to 2. So k squared plus 3k is equal to 2k plus 2. So k squared plus k minus 2 equals 0. Let's see. K squared. Wait, they've got k squared minus k plus 2 is equal to 0. Have I done something wrong somewhere? If I move that. They basically got mine. If I've done the k squared term wrong, then that would explain it. So let's see if I've done that k squared term wrong. K squared. Oh, no. That's not what they've said. They have said k squared plus k minus 2 is equal to 0. Okay, yeah, that's what I got. Okay, yeah. For this sequence, explain why k cannot be 1. Well, if k was 1, so if k was 1, then the sequence, okay, let's put it here. Let's label A. If k equals 1, then the sequence is given by this, an plus 2 over an, which is just 1 plus 2 over an. So obviously this can never like be periodic. Like if you start with a1 is equal to 2, then a2 is equal to 1 plus 2 over 2, which is just 2. a3 equals 1 plus 2 over 3, which is just, wait, 1 plus 2 over 3, which is 5 over 3. A4, let's see if I can do this. So 1 plus 2 over 5 over 3, so 1 plus 6 over 5. And what's that? 1 plus 6 over 5 is like 2.2. So you can see that it's not really going to be periodic. Actually, I can just prove it like this, because A4 is not A1, so it doesn't have order of 3. That's what I need to do, I think. But let's just make sure I've got that right, because 1 plus 2 over answer. Okay, I think I made a mistake on the A cubed, on the A3 term when I put it into my calculator. So A3 is just going to be 1 plus 2. Oh yeah, it's just 1 plus 2 over 2. I'm so silly. So, oh yeah, so it's just all going to be 2. So you can see it doesn't have an order of 3. Doesn't have an order of 3, because they're all the same term. Like so, okay. And now I feel like I'm going to need a bit of space for the next question, so let me just do this. Paste and match style. Okay. And find the value of that sum. And it's just a single sum. Okay. Let's see. So R starts at 1 and it goes all the way up to 80 of A of R. Okay. Okay. That is quite weird. So I suppose we can just start writing it out. So this is going to be A1 plus A2 plus A3 plus A4 plus A5 ... And obviously, now that we solved K, okay, so we can solve K because we've got K squared plus K minus 2 equals 0. We'll just solve K using this. K minus 1 is equal to 0. So K is either equal to 2 or 1, and we just proved it can't be 1, so therefore K is minus 2. Okay, nice. So we've got our thing. That means we've got our sequence without a K in it. We've got an plus 1 is minus 2 an plus 2 over an. Okay. And now we just gotta solve this, I believe. So what I'm thinking is, since it has a period of 3, if we just work out what A1, A2, and A3 are, then we can work out what all the other terms are going to be. So I already know that A1 is 2. Yeah, I know A1 is 2. And I know a formula for A2. So A2 is equal to 2K. 2K, which is equal to 2 times minus... Oh. So that's just going to be 2 times minus 2, which is minus 4. And A3 equals... A3 is K plus 1, which is just minus 2 plus 1, so minus 1. So now you can see this is just going to form a pattern like this, which means we can rewrite our sum like this: 2 minus 4 minus 1. That's going to just repeat. And then until, let's just put a few dots, and then AR. So at R is equal to 77. What's this going to be? So basically, you can see this is going to continue. R is 1, R is 3. It's going to carry on, you know. So R4, and if I add 4, let me think of this. Let's see. So 80 minus 4, that's 76. And the nearest one is 25. So there's going to be 25 multiples of this before you return. So R is 76. And that'll give you Sorry, this is a bit confusing. I think I understand the point. Basically, I'm just going to label each one. R is 1, R is 2, R is 3. And it's going to, this structure is going to continue. So if we were at, whenever R is 1 more than a multiple of 3, it's going to be 2. Okay, there we go. So if R was 76, this is 1 more than a multiple of 3, so it's going to be 2 minus 4 minus 1. So R equals 77. And then we've just got 2 more terms. And now we've got, when R is 79, that's going to be plus 2. Then 80, that's going to be minus 4. But there's no minus 1 term. Okay, there we go. And, okay. Now, between this and this, we're going to have how many multiples? So, 76. If R was, let's just say, 4, then that would be 1 multiple. So you do this number minus that, divide by 3. So 75 divided by 3 is 25. So there's 25 multiples of this, and plus 2 minus 4, which is, okay, there we go. That was pretty confusing, but I think I've got it in the end. I hope. Which is equal to negative 77. How odd. Okay. Yep. Okay. Okay, guys, we're back after a quick break, had to get a quick drink of water. Yeah, I have about 4 minutes left. So let's see if I can speed through these final questions. I don't know. Oh, no. A large, what is that? Oh, large spherical balloon. Okay. A large spherical balloon is deflated at time t seconds. At time t seconds, the balloon has radius r centimeters and volume v. Okay. The volume of the balloon is modeled as decreasing at a constant rate. Okay. Using this model, show that, okay, so the volume is decreasing at a constant rate. So that basically saying dv over dt is k. No, hang on, negative k, because it's decreasing. So that's what it's saying, and it wants me to show dr over dt is equal to negative k over r squared. Okay, then. Not too sure why. Let's see. The balloon has, yeah, okay. Okay, I guess this is just an integral, so I can just solve it like a regular integral. So, wait, but it wants me to show it in terms of dr and dt. So I probably shouldn't do that. I should probably, yeah, I just want to convert this dv into a dr. So dv, hang on. We know the volume of a spherical balloon is just going to be 4 over 3 pi r cubed, right? Yeah, okay. So we can just derive both sides. 4 over 3 pi, and then times by 3r squared dr. Okay, so that's just given us a formula for that, okay? 3 of dr And yeah, so now we just put that in. Then we just write a. So therefore, that is 4 over 3 pi multiplied, actually, it's 4 over 3 multiplied by 3, so I can just cancel this out. So it's 4 pi r squared dr over dt equals negative k. So dr by dt is equal to negative k over that. Okay. What did it want though? Over r squared. So that's basically, if you split this up, 4 pi multiplied by 1 over r squared. And yeah, so basically the k is going to include that. So yeah, I think I've shown it. I'm just right. K from answer includes 4 over 4 pi. That makes sense. So this is the k in the answer they want, because 4 pi is a constant. But yeah, okay, given that the initial radius of the balloon is 40, okay, r equals 40 when t equals 0. After 5 seconds, when t equals 5, is t measured in seconds? Yeah, t seconds. So after 5 seconds, the radius of the balloon is 20. Okay. The volume of the balloon continues to decrease at a constant rate. The volume of the balloon continues to decrease at a constant rate until the balloon is empty. Okay. Solve the differential equation to find a complete equation including linking r and t. Okay. Yeah, okay. Let's solve this differential equation then. So I guess it wants, yeah. So we have our differential equation. Now I'm just going to say, so part B, dr by dt is just going to be negative k over r squared. So if we move everything over here, so we've got r squared dr is equal to negative k dt. Integrate both sides, you get 1/3 r cubed is equal to minus kt plus c. And okay, so now you want to solve for both k and t. So you can just plug in these constants. So when t is 0, 1/3 40 cubed is equal to c. Yep. So c is just equal to that, which is going to be what? 21333.3 recurring. Okay. So I'll just say that's 40 cubed over 3. And when you put it into the second equation now, so now you have 1/3 20 cubed is equal to negative 5k plus c, so plus 40 cubed over 3. So let's just solve this all in one step. You get minus 1/5, 1/3 20 cubed minus 40 cubed over 3. So k is equal to minus 1/5, 1/3 times 20 cubed minus 40 cubed over 3. Okay. And that is 11200 over 3, which is 3733.3. So you get your final equation. You just want to link that and that. So you get 1/3 r cubed is equal to negative I'm just going to leave it in fraction form. T plus 40 cubed over 3. That is your equation. Okay, and finally, find the limitations. Wait, what? Limitations on the value of t for which the equation in part B is valid. Find the limitations on t. So, okay, yeah. So you basically want this to always be positive. So therefore, I'm just going to solve when this is 0. So t obviously has to be greater than 0. And also, let's just squeeze it into this. So also, we got to when you make this equal to 0, you can move the 11,200t to the other side. And, wait, let me just move the other stuff up. Okay, yeah, now we have a lot more space. So obviously the first constraint is that t has to be greater than 0 because you can't have negative time. So let's also find a critical value because r has to also be greater than 0. So when it's at 0, this is going to be the time. And now we just got to solve this. So t equals 1 over times 40 cubed. Let's see if this is good. So 5.714. So t has to be between 0. Actually, it can be equal to 0 though, I think. So that is the limitations. 5.714285714. Okay, I hope that is correct. Question 15. The curve C has equation x squared tan y is equal to 9. Okay, show that dy by dx is equal to that. Okay, pretty good question. 4 marks, good work, good work. So let's just solve it up here. X squared tan y is equal to 9. Probably just going to differentiate implicitly on this. So use product rule. 2x dx tan y plus x squared. You need to differentiate tan y. I'm pretty sure it's just secant squared y dy is equal to 0. When you differentiate 9, you do in fact get 0. Okay, and now what am I going to do here now? So we got to gather like terms first. Yeah, so I'll move 1 to the other side. So now we got 2x dx. Actually, let's just move the dx to the other side. 2x tan y dx is equal to negative x squared secant squared y dy. So therefore, dy by dx is equal to, when you move this over to here, and you're going to move this stuff over there. Okay, so you've got 2x tan y over minus x squared secant squared y. Let's see what it wants now. So it's telling me dy by dx is minus 81x over x to the 4 plus 81. Oh, hang on. I think that is a minus 18x. Okay, minus 18x plus 81. Yeah, okay. So how am I going to prove that? Yeah, that's a bit weird, actually. That's a bit weird. Why is it just lost all its trigonometric functions? Okay, let's see if there's some cancelling that goes on over here. So the tan y, we're going to write that as sine y over cos y, and over secant squared, well, that's going to be over 1 over cos, so that's just going to be cos squared over 1. So we do get one cancellation, but is it enough? Equals 2x over minus x squared multiplied by sine y cos y. Okay. Now where do we go from here? Because how has that managed to get minus 18x plus x to 4 plus 81 from this, man? I mean, Okay, I know you can rewrite. Okay, let's just do a bit more cancellation. So you can just get rid of the 2 on top. That's just minus x multiplied by sine y cos y. Oh, I get it. It's all in terms of x, so we have to put y in terms of x. Okay, that's good, that's good. So we know tan y is equal to 9 over x squared. So therefore, y is equal to arctan of that. Okay, there we go. And we know that this, if we use the sine double angle formula, it's just the same as 1/2 sine of 2x. Like, sine of 2y, I mean. Sine of 2y. Okay, so now our mission is just to simplify this. So we're basically trying to put sine 2 of, and we know y is arctan of 9 over 2x squared. So what usually helps is to draw out the unit circle here. And if we just label this bit as theta, not a unit circle, Pythagoras, or just a triangle. So theta. So we know tan, if we say theta is equal to tan minus 1 of 9 over x squared, then tan theta is equal to 9 over x squared. And you know that's equal to opposite over adjacent. So opposite adjacent, and therefore this is just x squared, no, x to the 4 plus 81. Okay, so now you can work out sine of 2 theta. Okay, yeah, this isn't actually going to, we probably shouldn't have used the double angle formula because it's a bit complicated because you have to expand out anyway. Sine y cos y, like so. So now you can get sine of theta. Yeah. And this is equal to y. So if we want to find sine y, that's the same as sine of theta, because we've just worked out that y is equal to this, and then we've just put theta equal to that just because it's an angle. But yeah, so if we just work out sine theta, that's going to be equal to, sine theta is opposite over hypotenuse. So 9 over hypotenuse, which is this, and cos theta is adjacent over hypotenuse, so x squared over that. Okay, there we go. And move all this up. Got this all the way over there. Rub that out. Okay, so now we finally get dy by dx is equal to 2 over minus x multiplied by 1/2 9 over this plus 81 multiplied by x squared over this. Okay, get a bit of cancellation. The x is also cancelled, so we're left with 9x over this times this, which is, I'm just going to move the negative up here as well, minus that, minus 9. If you move this over here, when you square those two, you get x plus 81. Okay, we're definitely a bit closer now. And one small error. I've made one small error somewhere, because they've got an 18 and I've got a 9. So where's my error? The 18 has probably come from timesing this by this. Oh, yeah. Silly me, you don't need the 1/2 if I'm not going to cancel anything. So the 1/2 here just shouldn't exist. And yeah, that means I can't cancel that out. That's still 2, which makes it 18x. Okay, there we go. And then finally, prove that C has a point of inflection at x equals that. So you're working out dy by dx. Point of inflection basically just means second derivative is also equal to that. So let's work out second derivative then. D squared y over dx squared. This time I just use quotient rules. So I won't bother to simplify it because you don't need to. I just need to verify it. So it has a point of inflection. So v du, gonna have x to the 4 plus 81 minus du, which is just minus 18, minus u dv minus 18x multiplied by dv, so 4x squared cubed over this v squared. Okay, when x is equal to 4 over 27, I'm just going to type it into my calculator. So this should now just give us the answer we're looking for. So 27 to these, to the 4 through, and then we're just going to type it in. Answer to the 4 plus 81 multiplied minus 18 minus 18 answer times 4 times the answer cubed. Okay, let's just ensure I've got that right. Okay, looks promising. And all over this squared, answer to the 4 to the 4 plus 81 squared, which does equal 0. Okay, there we go. That was pretty rough. But now moving on to the question 16, which I hope is the last one. Prove by contradiction. Oof. Okay. Prove by contradiction that there are no positive no positive integers p and q such that, okay, contradiction. So 4p squared minus q squared is equal to 25. Okay, no positive integers, and you want to prove by contradiction. So let's say p, q are both integers. Then this is going to be an integer. How am I going to do this? So, okay, let's split this into difference of two squares. So we've got 4p plus q and 4p, oh, nope, 2p plus q and 2p minus q is equal to 25. Okay, I think it's going to be something to do with odd and even numbers. Yeah, okay. So if they're both integers, then this is even, which means this is odd. And this is also odd, because even minus... Actually, you don't know that. You do not know that. Oof, that is difficult. Because you don't know if it's odd or even. So... Okay. Okay. So, you know for sure this is even. These are both even. But now it depends on if q is odd or even. So, let's put it into cases. So, if q is odd, then it's going to be an odd multiplied by an odd, which could be an odd. Okay, so this is the one which it could be odd, because if q is even, then it's going to be even times even, which gives even. Gives even can never be and it can never be 25, since 25 is odd. I don't know how much we have to prove it. Let's see. Prove that there are no positive integers. Yeah, so we have to prove everything, not just if q is even. So let's look back at case 1. So if q was an odd number, okay, yeah. Okay, I think I got it. Now I also have to look at factor pairs. So if q was odd, then 2p plus q. So this is going to be, it's basically saying 2p minus q and 2p plus q is equal to 25. So it's saying 2 consecutive odd integers multiply to 25. So that's what it's saying. But obviously, if we look at the factor pairs of 25, 25 is 1 times 25, it's 5 times 5, and it's nothing else. So there are no integers which satisfy this. Therefore, no possible values for p and q being positive integers, and therefore contradiction. So they cannot be positive integers. Okay, there we go. Okay, and that is the paper over. So I actually did go way over time. Even if you subtract the 4 minutes, which I took a break for, I started at 9:23. Yeah, started at 9:23. It's currently 11:49, but if I take away the 4 minutes, that is now, what's that? 2 hours and 22 minutes. So I guess that's the penalty I had to pay for doing it, because it's a 2-hour exam, and it's a 2-hour exam, 22 minutes over, so that is the penalty I had to pay for doing it upside down. But yeah, thanks for watching. I'll now go over the mark scheme and let you know if I got any of them wrong. But thanks for watching, and yeah, I'll see you guys later. So guys, it turns out I actually got question 8 wrong. All it wanted was an exponential equation, so I didn't actually need to do this differential equation stuff then integrating. I mean, it probably should have made sense because there's only 2 marks, but yeah, this is only, yeah, all you need to do is put n is equal to an exponential equation like this. Although, if you look at this, right, I think we can just rearrange this. So if we say k ln n is equal to t minus c, then we've got ln n is equal to 1 over k t minus c. So n is going to be e to this power, e to the k, multiplied by t minus c, like so. And basically, that's equal to e to the 1 over k. Wait, hang on, is it? Yeah, so if we expand this out, minus that, so that's multiplied by e to the minus c over k. And as you can see, this is just a constant. So this is going to be like the a constant. And this is the 1 over kt. Well, 1 over k is just similar to a constant. So this is like similar to it, but it's not like, basically I think I asked for it in terms of n. So yeah, this is probably just wrong. I will just give myself a -2 for this. But yeah, that was not the right method. So yeah, beware of these kind of questions. Just remember it's an exponential function and you can just write anything like that. So yeah. Okay guys, yeah, it turns out I also got 9c wrong, CII to be specific, but basically what I forgot to look at was that x has to be greater than 0, so we're just ignoring all of this side here. So basically what that says is, if we shift it 3 up, we basically, the lowest bound is going to be the y-intercept here, and the highest thing is going to be this, which gets moved up to here. So this is the range, like this, which is why, if you look at the mark scheme, the range is actually -19. So you could work out the y-intercept of the original f of x, or just g of x. Actually, it wouldn't matter, but yeah, so if you just put 0 into this, you'd probably get 16, right? 0, 1, 2. You would get -2, you'd get -8, and then multiply by 2. Yep, so you get -16, then you have to -9. And similar for this, you just do the same transformations to our maximum point over here. And yeah, that's how you get E. So that's how you get the range. So this is the actual range. So I just got that one completely wrong. So that is -2 as well. Yeah, okay. No, guys, we got this one wrong, man. We spent so long in it, but it's not 25, it's 26. Oh, man. So basically, this is going to have 26 repeats of this, because we forgot to include this extra one here. We did 76 minus 1 to give us 75 terms, and that's going to give us 25 like triplets. But we forgot to include this extra triplet after the 76, which would have been the 26th triplet. So this is actually meant to be 26, which actually comes out to -80. So honestly, I don't know how many marks I would have lost here. Let's just read the mark scheme. So, okay, so we did do mark B1. We didn't get these two because we put 25 instead. So that is a -2. Okay, question 15b, we have lost another mark. Basically, to prove it's a point of inflection, you can't just put this equal to 0. You can't just put this into the second derivative and show it's equal to 0, because you also need to show that when x is before it, second derivative is less than 0. So basically that's showing that it's changing, but otherwise it could also be like, I don't really know how to explain it. It could just be a turning point and not a point of inflection, if that makes sense, you know? So yeah, you need to show both of those, and only then you get the accuracy marks. So you can't just show that it's equal to 0 if you put x in. So yeah, you need to show it's not a turning point. So that is another -1. Okay. Okay, so the final question, this is a bit weird because I think my proof still works, but it's not really in the mark scheme, if that makes sense. It's just the way it's been phrased. But yeah, so I'll explain the easier way of doing it. Basically, we have... where is it? Okay, yeah, so if we go from here, we can just split this into 25's factor pairs. Like so. 25 times 1. So basically, we can just set this and this. They both have to equal 5. However, that would never happen because if this had to be equal to 5, then P would either have to be 2 and Q have to be 0.5. Or, sorry, if you want to make this equal to 5, then you can have P as 2 and Q as 1. That'll work here, but it won't work here. And similarly, if you want to solve it here, you'd have to get these simultaneous equations and there'd just be no integer solutions. So that's how you'd prove that. And there's these old things. But yeah, so the way they've done it is they've also considered P as even or odd as well. But yeah, I believe you need to be a bit more rigorous. So probably going to take away 2 or 3 marks, I think, because I did get the completed square, but other than that, I don't think I've got another one. So I'm probably going to take away 3 marks for this one. But yeah, I think this was the final question. Other than that, everything else was correct. So let's just go back to the start. So we got -3 there. Here's -4. There is a -6. -6, -8, -10. Right, this is looking quite rough. Yeah, okay, -10. So let's just calculate percentage. I don't actually know what it's out of. Let me just check somewhere. Yeah, I do not know what this is out of. Oh, hold on. The total mark for this paper is 100. I did just turn over to look at that, but that gives me 9 of 100. It's alright, but I did go over the time limit, and yeah, I mean, it's alright, although I was doing it upside down. So thanks for watching, and I'll see you guys in a future tutorial. See you later, and bye.